So now in this playlist, as I have already done all the binary search medium questions, now let's just quickly try to solve all other medium questions also. Let's just start with this matrix one first. So this question states that you are given an n cross n 2D matrix. Basically it is a 2D square matrix representing an image. Rotate the image by 90-degree clockwise. You have to rotate the image in place, so that basically this means is that we can't use another 2D matrix for our help. So we need to do in place kind of things to rotate it to 90 degrees clockwise. So if our matrix is something like this 1 2 3 4 5 6 7 8 9, we have to rotate it 90 degree. Basically it will be a rotation of a 90 degree like this. So this 1 will go here, then 2 will come here, and 3 will come here. Let me just show you how this thing is happening. Let me just copy the matrix. So it's something like this. And what is the 90-degree rotation clockwise means here is that what they are doing is they are rotating it like this. This is a 90-degree clockwise rotation. So by doing this, this one row will be rotated 90 degree like in this angle, and the new array will become something like this. This 1 2 3 will go here like this, 1 2 3. Okay, now let's just see this row. This row will also get 90 degree rotated like this. So it will be something like 4 5 6, and at last this row will rotate like this, and it will become 7 8 9. 7 8 9 4 5 6 1 2 3. 7 8 9 4 5 6 1 2 3. So this is how 90-degree rotation is occurring in this question. If you can observe this clearly, this is not a transpose. Basically 90-degree rotation is not equal to transpose, because let's say if our matrix is this 1 2 3 4 5 6 7 8 9, then its transpose, basically let's just call this matrix A, then transpose of this matrix A will be something like this. So this is the transpose of the matrix A. Clearly you can see that let's call this rotation of A. So clearly transpose of A is not equal to rotation of A. Rotation of A is something like this, where 1 2 3 column is occurring at the rightmost side, but here in the transpose it is at the left side. As you know, in the transpose we just replace the rows with the column and the column with the rows. So this is how you perform transpose. But in the 90-degree rotation, it is something like a clockwise movement that we are doing. This 1 2 3, which was the first row, is becoming the last column. But in the transpose thing, the first row was becoming the first column only. Let's suppose we somehow know how to calculate a transpose of a matrix let's suppose we know how to get this from I. Let's say if our input is a, and we know how to get this transpose of a. If we know this, let's suppose there is some black box for this thing, then how we can reach to rotation of a. As you know, rotation of a is something like this: 1 2 3 4 5 6 7 8 9. So how to reach from here, from the transpose to here? How we can reach here? One observation you can simply make here is that we can just swap the columns. We can swap this column with this, and then we will get this. Okay, so this is how you can get a rotation of a using a transpose of a. Yes, and the swapping of the elements will be very easy to do, because what we can do is, we can, let's say if we have this row, if we focus on this row only, then we will run our for loop from I equals 0 to n by 2 to reach here, and what we will do is, we will swap this with this by using n minus I kind of operation. We will swap this element with this, and we will get 7 4 1 as an answer. This is how we will get a one specific row using transpose matrix of a to get the rotation of a that this question is trying to get as an answer. I hope this is quite clear to you guys, but how we can perform the transpose? Because I have said, let's suppose there is a black box to get this transpose of a, but we need to calculate this transpose of a also in order to rotate this a, because it is a two step kind of thing. Let me just quickly draw a flow chart so that you can get a better idea what we are doing and how we are doing it. It is, we have our input a, this is our array which is given to us by the question. What we need to output is 90-degree rotation of this a. We needed this thing. So how we are doing this question is that we will make an intermediate step which is nothing but a transpose of a, and using this transpose of a we will reach this 90-degree rotation, as I have said you. And how to reach from a to transpose of a, we will do in maths. It is very clear that a transpose of a matrix a, you can think of it as like swapping of rows with the column. Whatever the row was there, now there will be the column, and whatever the column was earlier, now the row will be there. See, in the transpose thing, see, this column was at the 0th place, so in place of this column there will be the row that was at the 0th place. See, in the transpose of this, here now there is the row that was in the 0th place. So what we are doing is, we are just replacing our row to column and column to row. So how to do that? So to do that, we will just simply use something like this, that matrix of I comma j is now equal to matrix of j comma I. This is how you will swap both column to rows and rows to column, because if you know the for loop structure, the first I is signify row and the second jth iteration signifying the column. And here what we are doing is, we are replacing our row to column and our column to the row. This is how we will swap and get the transpose of a. So transpose of A is kind of easy to get because it is just a single statement, which is this, to get the transpose of A. Now using this transpose of A, we can rotate it to our appropriate answer that this question is trying to get from us by doing this kind of operation, which I have already shown. This kind of operation that let's say the length of matrix is n, at is this is n cross n matrix, so the length will be n in the both ways, so that is not the issue. So now let's say we have our transpose of A by using this formula. We have this. Now how to get this rotation of A is we can do something like matrix of I comma j is equal to matrix of I n minus j or something. Basically this will be a swapping, so we need to like store this and we need to like replace this also. Let me just show you, let me just write the exact statement. We will first make a temporary variable t. I hope you know how to swap. The swapping occurs by making a new variable, a temporary variable, let's say t, and we will store our matrix of I comma j there. Let's say here we store our matrix of I comma j in this t variable. If we store it here, then what we will do is we will update this matrix of I comma j. And how to update it is by using this formula. That matrix of I comma j now becomes matrix of I n minus j. It is something like now matrix of I comma j becomes n minus j, which was this element. So we will swap these two, and if we swap these two, then it is quite clear that we will get our appropriate answer that we are trying to find. So basically swapping will occur like this element will get swapped with this element will get swapped with this, and as this element is in the middle, so there is no need to swap because we will write something like we will run to the n by 2th only, not the whole array. And there is no effect on the rows because we are just interchanging the elements of a one particular row only, because if we are at this row we will only change this to this, and let's say this will remain same because it is in the middle, but we are not hindering the other rows elements, we are not touching them. So that's why in this formula we are only changing the columns element. See, the columns are changing. No, if we get to a particular row, that means the ith row, we get to the particular row, then we only need to change the elements column wise in that. That's why this formula is there. I hope this is now clear. Let me just quickly write the algorithm for this so that you can get clear idea for this, why and how this was occurring. And as I will write the code, I will try to explain this more. Basically the flowchart will remain this only, that we will have our input A, we will first change to it to get its transpose, then we will use this formula to get its 90-degree rotation. Okay, so let me just quickly solve the question. As it is a square matrix, so the length of both rows and column is same n, so there is no need to do that differently. I will just use this only to get the size of the matrix. Now at starting we need to like have a transpose of this, and as I have already shown you how to get the transpose of a matrix is by using this formula here. This is the formula to have a transpose of a matrix A. Basically we will interchange just row with the column and column with the row. It is just swapping of those things. So now we have to do the transpose, and to do the transpose we will run our for loop 2 times, and I plus plus. This I will signify the row, and this variable j will signify the column. Now we will swap using this formula, that our matrix of I j is equal to matrix of j comma I. But we are doing something like a swapping, so we need to like first store these into one variable. Let's say basically you know how to swap the elements, right? We are just swapping these two elements, so we will first need to store this in some variable t, then we will assign this to this, and we will assign this to this, and that's how you perform a swapping, right? I hope you know how to do a swap. It is quite simple, but the main formula is this. So let's just make our temporary variable t. It will be matrix of I comma j, and what we have to do is we have to interchange, we have to swap. So we will do matrix of I comma j is equal to matrix of j comma I. This is something like we are changing our row to the column and column to the row. As you know, I is signifying the row and j is signifying the column. And at last we will just do this, that matrix of j comma I is equal to our t, meaning matrix of j comma I is now matrix of I comma j. So what we are doing is we are assigning matrix of I comma j to matrix of j comma I, and matrix of j comma I to matrix of I comma j. Let me just write it here only, that what we are doing is we are assigning matrix of I comma j to matrix of j comma I, and we are also doing matrix of j comma I to matrix of I comma j. This is how we are doing this. Now in this transpose calculation there is one error. Let me just show you and quickly do a dry run so you get a better understanding and we encounter our error also. So let's suppose our array is this only, and we need to get the transpose of this, that is something like this, that this 1 2 3 will be now column, and this 4 5 6 will be now in the middle as a column, and this will go to the end like this. So this is the transpose of matrix A. Let's suppose this is the matrix A and this will be the transpose of A. So we are trying to get this by using these two formulas. We are trying to get the transpose of A. Okay, so let's just quickly do a dry run on this so that you can get better understanding why this formula is useful here and why this formula will fail in this case, because of the bounds which we are using. Basically we are initializing our row to 0 and our column to 0 also. We are starting both of them to the 0, so it will go to the each element again and again, and the swapping will occur 2 times. So something will occur like this, that let's suppose this is how we are doing a swapping, that let's suppose okay, so this is our initial case, that Okay, so we are trying to get this only, right? We are trying to get from A to this B using that formula above I mentioned. So quickly try to do our dry run. Firstly, our I will be 0 and our J will be 0. And when our I will be 0 and J will be 0, we will get this matrix of I comma J, that is 0 comma 0, which will be equal to 1 at the start, this 1 at the start, and our matrix of J comma I will also be 0 comma 0, because here both of them are same, so it will be something like 0 comma 0, that will be also 1. So we will swap this 1 to 1, basically nothing will happen, and this will get pasted like this only. This one will now get here. This one is now at the correct position. Okay, so now the next iteration will occur, and that will be something like I will be 0, but our J will be J equal to 1, right? In that case, our matrix of I comma J will be something like 0 comma 1, and that is 2, so that will be 2, but our matrix of J comma I, that will be 1 comma 0, is actually 4, because matrix of 1 comma 0 will be this element, so this will be 4. And now we will swap this 2 with the 4, we will swap these two, and we will get something like this. Now these are also in the correct position, because we will swap these two, and if we swap these two, this 2 will go here and this 4 will go here, and we will get this kind of structure. So till now everything is good, and we are getting our transpose, this transpose, we are getting that. Now let's just do the third iteration. Whenever I will be 0 and our J will be 2, in that case also everything will work. It will be something like this, and matrix of 0 comma 2 is actually 3, and matrix of J comma I, that will be 2 comma 0, is actually 2 comma 0 will be this 7. And we will at last we will swap these two, and when we do a swapping of this with this, we will get something like 1 4 3 1 and 1 2 3 and 1 4 7. So basically this 3 will come here and this 7 will go there, and we will get our appropriate transpose, right? So what is the issue here? Why I am saying that the issue will occur? The issue will occur because this for loop will run more times basically. Now what will happen is, now as all the column is over, basically this jth row is over, so we will go to the next ith one. So it will be something like I is equal to 1, but J will be equal to 0. Now see, in this case when we calculate our matrix of I comma J, what will be our matrix of I comma J? Matrix of I comma J will be 1 comma 0, and see now the updated array is this, so matrix of 1 comma 0 will be this 2, so this will be this 2, and matrix of J comma I in this case will be 0 comma 1, and see what is that is this 4. And now we will swap these two, because we are doing a swapping. So if we do the swapping of these two again, what will happen is this will get swapped to 2, and this will get swapped to our 4, and this will lead back to our original array only. Similarly, when we go to I is equal to 2, J is equal to 0, this will also get swapped back. So we will get our original array only. So what was happening is that we were trying to go from here to here, but what is happening is, when we are doing a for loop from 0 to n and j 0 to n, what is happening is that from our a we are going to our b. See, I have shown you how we get to our b, but if we don't restrict our bounds, if we don't restrict into some appropriate boundaries, what will happen is that reswapping of this b will occur, and this b will again go to our a only. So in very layman terms, what is happening is that, let's suppose there is something like this 1 2 3. What is happening is that for the first iteration we are doing everything correctly, that after the first step, our swap is occurring correctly, that this is something is happening. But as we are not breaking our for loop, this for loop will again swap this for loop will again swap these two again, something like this. Now this will get swapped to this, and we will get our original, that was we are trying to swap. We will get our original array only. So in order to restrict this thing, we need to do one change only here, that we will not start from j is equal to 0, but we will start from I plus 1th one. I plus 1th. Now this will work because we are not redoing the swapping. Basically it is something like minus minus is coming out to be plus. We are reversing a and b to get b comma a, but we are again reversing that b comma a to get a comma b. But restricting this to only one time reversing, we will get our appropriate answer b comma a. So in this case we will get our transpose of matrix A. I hope this is clear, that how to get a transpose of a matrix. Okay. Now what we have to do is, now the transpose of a matrix is done. Now this transpose of a matrix we have calculated it. Now we just need to do a 90-degree rotation to get something like this: 7 8 9 4 5 6 and 1 2 3. We have this, we have gotten this. Now it is quite easy. Again you can note that this row is coming out to be here. Basically the swapping of this 1 and 2 is occurring, this swapping and of these two are occurring. These two are swapping, these two are swapped, these two are swapped, and if we do that, we will get our answer. So let's just quickly do that. Again our for loop will go from I is equal to 0 to n. Again there will be a nested loop. Now in this case, what will be our starting condition? Our starting will be let's by running this for loop at the outer for loop, we have restricted our row to a particular ith row. So now we just need to focus on a particular column. Let's suppose our column is this. We have to get something like this, that our 5, then our 4, then our 3, then our 2, and then our 1. We have to get this. Basically we are swapping this with this, we are swapping this with this, and this is in the middle, so we don't need to swap that, or you can do that also. Basically the 3,3 swap will lead to 3 only. So we need to do just this reversing only, and there are many ways to reverse this. What you can do is, you can maintain a pointer j is equal to 0, and here it will be n minus 1, and we will do swapping something like this, that matrix of I comma j is equal to, first store it, let's say it is in some temporary variable t, and then we will change our matrix of I comma j to something like matrix of I, because the row is remaining the same, so we will not change our ith thing, we will just need to change our column one. And the column one that we are trying to replace, it will be something like n minus I, sorry, n, yeah, n minus I plus 1, because if we calculate this, it will be something like n minus 0 plus 1, it will be minus 1, here it will be minus 1, because if we do that, let's suppose our, in the first iteration when j is equal to 0 and our n is whatever, uh, then our n minus I minus 1 will give n minus 1, and we will get appropriate index to swap this one with. Now when our j is equal to 1, we need this element, it is at n minus 2, so to get that we will use this formula only, that n minus 1, n minus 1 minus 1, so we will get n minus 2, and then we will swap these two only, these two. But again we have to like restrict the swapping, because if we go past this element, then we will again swap these two and our effect will get reversed. Basically if we don't stop our jth loop till here, then what will happen is it will go till here, and when it reaches this 2 again, basically now this is reversed, so now here it is 2, now this 2 will get reversed with the 4 again, and we will get our original array back. So we don't need that, so we have to restrict it into the half part, because we are accessing this, this and this and this via n minus ith thing, and we will replace these two, basically we will swap these two. I hope this is now clear to you guys, because I have explained it into the real depth of this, how these pointer are changing and what they mean exactly in this case. So yeah, so we will start out from j is equal to 0 to j less than our n by 2, and we will do something like j plus plus. I hope this is now clear why in our jth, basically in our column, we are not going from j less than n. Why we are not going to n, and we are restricting our n to n by 2 only. Now we will maintain our temporary variable, that int t is equal to matrix of j comma I, and this is quite standard swapping, this is nothing complex here. This is the same formula I have derived in the tab. And now we will do our swapping. Okay, there is some error occurring. Maybe we have to go till j n by 2 to less than equal to n by 2, because we need to like take care of that also. Okay, still there is some issue. This is matrix of I comma j, not j comma I. This will lead to the out of bound error, as I think. Yep. So this has to be this thing only. What is happening is that our output is something like 15 to 13.5, but it is expecting 15 to 13.5. It is expecting 15 13 to 5. So there is a problem between these two swap. So our this condition is failing somehow. Maybe this is the correct answer only. So finally this get accepted, all the test cases passed. I hope this is now completely clear to you. Now we have done our first question of matrix. Now let's just quickly try to solve this question also. Let me just remove the code. Okay, so this question is asking that we have a matrix M cross N matrix. It is a rectangular matrix. Return all elements of the matrix in spiral order. So what we have is something like a matrix like this: 1 2 3 4 5 6 7 8 9. What we have to do is we have to return an array list of integers in such a order that this patterns or this sequence get followed, that 1 2 then 3 then 6 then 9 then 8 then 7 then 4 then 5, and we have to return this array list as our answer. It is kind of like a cycle that is going on. It is a pattern, as you can see here. It is some kind of a pattern. So how to solve this question? Because for this question to solve we need 4 pointers: our column start, row start, column end and row end, in order to solve this question. Okay, so let me just quickly try to explain it in depth, that how to approach this question and how to solve this question. Okay, so let's just initialize our matrix with these numbers. Let's make a 5 cross 5 matrix. Ten, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Okay, so let's just keep it simpler only. No need to do a 5 cross 5. This is 5 cross 4 matrix. Basically there are 20 elements. So what we have to do is we have to return an array list in such a order that we first print 1, then this 2, then this 3, then this 4, then this 5. Basically first we do something like this, we traverse like this, then when we reach the end of this we go downwards. So we will do 10, then 15, then 20, and once we again hit the boundary we will go to left this time. we will print this 19, then we will go to 18, we will print that, then 17, then 16. Again we have hit the boundary. Here also we have hit the boundary. So now in the third time when we are turning our road, we will go upward this time. Then after 16 we have to print 11, then 6. Now see, in theory what we have to do is we have to go upward because there is one, but one is already done. We have already printed or we have already returned this one here, so there is no need to go more up. Now what we have to do is we have to again go right, because we have reached the new boundary here. We have reached the upper boundary here, so what we have to do is we have to go in the right direction again. After the 6 we will print 7, then our 8, then our 9. And see, now again we have to like go on the right side, but as 10 is already been added in our array list, we have reached the boundary again. So at now this time we will go downward, and we will print this 14, then we will print this 13, and then we will print this 12. And now as all the elements have been added in our array list, we will simply return this array list. So if you see the pattern clearly, the pattern is something like, first we are going left to right. First is left to right, then we are going top to bottom, then we are going top to bottom, then we are going right to left, and finally we are going from bottom to top. And again we will repeat this cycle, that we will go to left to right, then top to bottom, then right to left, then bottom to top, and again we will repeat this cycle until all the elements have been fulfilled. So we will just connect this loop here. So I hope this pattern is now completely understood to you guys, that how we are traversing. And in order to do this pattern wise sequence printing, what we have to maintain is we have to like maintain the boundaries where we need to turn our traversal. So we have to maintain, let's say, our starting left, we have to maintain our starting row, starting column, our ending column, and our ending row. We have to maintain these 4 pointers in order to do this spiral kind of traversal. Because let's say at start we will initialize our starting row to 0. At start it will be 0. Our starting column will also be 0. Our ending column will be this m-1 or n-1, and our end column will be this n-1, and ending row will be m-1, something like this. So what we will do is we will start from starting row 0 to our end row. Basically, to do this thing, we have to do it from starting column to ending column. Let me just write the code in order to explain it in more depth. So it is a m cross n matrix. Basically there are m rows and there are n columns. So let's just initialize it that way. Int m is equal to matrix dot length, and int n is equal to matrix of 0 dot length. Now we will initialize our 4 pointers, which will determine the window of our traveling in a particular for loop. As I will write the code, you get a better understanding of how we are approaching this question. So the first variable will be starting row, and the starting row will be starting from the top left, so it will start from s underscore r is equal to 0, and our column, starting column, will also be 0. Then our ending row is this whole matrix last row, that is this last row, which will be m minus 1. So that will be m minus 1, and our end column will initially be at this last column, and this last column is basically in m cross n matrix is n minus 1, so it will be like this. So this is our initial configuration of these variable. Now we have to like travel it in. We have to like start a while loop in order to travel our matrix in spiral order. So what we can do is, while our start row is less than equal to end row, and our start column is less than equal to end column, we will run this while loop. Otherwise we will stop the while traversal and return our answer. So let's just make our array list which we have to return. Finally we have to return this array list, so let's just return that, return ans. Now the main core logic of this traversal in spiral order will go in this while loop, and let me just explain this why and how this while condition is there, that why we are only writing this condition only. Okay, so let's say our initial configuration, as I have already told you, is something like our starting column will be 0, our starting row will be 0, our ending row will be m minus 1, and our ending column will be n minus 1. So let me just quickly do a dry run of this. Okay, so this is more than enough for a dry run. Basically we have this much row, we have 3 rows, so our m will be equal to 3 and our n will be equal to 4 because it is a m cross n matrix. So this will be how it will look. This is our m and this is our n. So I am just putting the values in them. According to it, our end row will be m minus 1, end row will be 2, and our end column will be 3. So by doing this, what we have is, we have something like our starting column will be 0, our starting row will be 0. So this will be our starting one. And see what is our ending column. Ending column is basically 3, which is here 0 1 2 3 here. So this is our ending column at start, and our ending row will be at 2, that is this row, because it is something like 0 1 2. So this is our ending column initially. as you know, I have already told you how this traversal will go. It will go from left to right first. So it will go from starting column till ending column. So this will be our first for loop that will go from left to right. Basically this is nothing but left to right. We are going from starting column to our ending column, and this is how it will look visually. And when we have done this thing, we have already added these into our answer. Basically in the for loop we will do something like ans dot add our matrix of I comma j or something like that. We will do that. So these all elements will get added. Then after this left to right we have to do top to bottom. Now we have to go top to bottom, and in order to go from top to bottom, first we have to reduce our starting row. See, clearly here the starting row have been processed, have been added to our answer, and we don't need to like re-add this 1 or 2 or 3 again and again, and our as one starting row is already been processed. So after this for loop we will do something like s underscore r, basically starting row plus plus, signifying we have already processed our starting row. Now what we have to do is we have to go from top to bottom. And how to go from top to bottom in the right side, what we will do is we will use the starting row. Now the starting row will come here because we have done starting row plus plus. So now our starting row is here, and we will run our for loop from starting row to our ending row, because our starting row will be here and we have to add these two elements in our answer. So we will go from starting row to our ending row, and this will access by the ending column. So we will do something like this. In our for loop we will do ans dot add this matrix of I comma this end row, and in the above for loop basically this starting for loop we will do like from s underscore c we are going to e underscore c. Basically we are changing the columns thing. So and our row is remaining the fix here, s underscore r. So we will do something like matrix of starting row comma I. This I will be the variable which we will use in this for loop to traverse. Now after this for loop also we are traversing something like this, that s underscore r to end underscore r, starting row to our ending row, starting row to our ending row. So these will also get processed and added to our answer. And when we add these also in our answer, you can clearly see that now we have to reduce our ending column, because this column is not our end anymore. We have completed this. So now our search or our restricted window is smaller, so we have to restrict it. So how to like reduce that? We will do end underscore c minus minus. After this for loop we will do something like end column is now processed. So now let's restrict that, because we don't need to add these again and again. We have already done, and we have done our work for end column for this particular iteration. Now we have to reduce our end column to here, because now end column is here. I hope this is clear. now after top to bottom we have to go from right to left, and in order to go from right to left, what we can do is we can do something like we will go from end column to our starting column in our end row. And once this is also processed, after this for loop we will do end row minus minus, signifying this end row is also being processed. Now we will at last go from bottom to top, something like this. We will go from end row to our starting row, and once this for loop ends we will do something like we will increase our starting column, because now this column has been also processed, so we will shift our column to the next one. So we will do something like this in the last. I hope the dry run is completely clear to you guys. So let me just quickly write the code here. So at start we have to go from left to right, and in order to go from left to right, what we have to do is we have to start from starting column till our end column. So we will do something like this: for int I is equal to starting column till our ending column. We will do I plus plus, and we will add our element in the answer. See, when we are in a particular row here, the starting row, this row is fixed. This row will be the fixed because we are going column wise. First we will need this 1, then 2, then 3. So only the second element is changing. Our row is remaining the fixed. So what we have to write in the row column will be this starting row, because at start we will be at the starting row, and we are only traversing column wise, so here the I will come. Now after this for loop, what we will do is, as this row is being processed, this row has been already added in our answer, we will just increase our s underscore r plus plus to the next row, signifying that this row is no longer the starting row. Now this is the starting row. So we will do something like s underscore r plus plus. Now we have done left to right. Second step to do is we have to go from top to bottom, this top to bottom, and that too in the right side. So in order to do that, we have to go from starting row to our end row. So this time our row will change, rowth index will change, and the column will remain same. The column will be end underscore column, because we are in the rightmost column. So let me just quickly write that. For this time our row will change, so for int I is equal to starting row till our end row. Starting row till our end row, we will do I plus plus, and we will add all the elements in our answer. Now in this case the row is changing, so in the first box we will write I, and in the second box, as the column is remaining the fixed, that is this end column, we will just specify that here like this. And after all the elements of this top to bottom gets added, this column gets processed, this column gets fully processed. So what we will do is we will update this end column to end column minus minus, signifying that this is now our new end of the matrix. So we will do something like this: end column minus minus. Now we have done left to right and top to bottom. Now we have to go from left to right, and in order to go from left to right, we have to start our iteration from end column to start column, end column to start column, and our row will remain the fixed, that is the bottom row, and the bottom row is getting stored in end row variable. So we will do something like this: for int I is equal to end column to start column, end column to start column, we will add that again. Now our row is remaining the fixed, that is the bottom row, signifying by this end underscore r. We will write that here, and our column is getting changed, so variable, the iterator will be in the column box. And when this end row gets processed, we will just update our end row variable, signifying that we have already processed this end row. Now we have to go upper. This is our new endth row. So we will do something like end row minus minus. Now we have done our traversing of spiral order from left to right to top to bottom, then left to right. Now we will go from bottom to top, and in order to go from bottom to top, we have to traverse through end row till our starting row, end row till our starting row, and our starting column will remain same. So we will write a for loop for that. For int I is equal to now end row to start row, end row till our start row I minus minus. We will add that in our answer. And in this case, as our row is getting changed from end row to start row, so our rowth box will have I, but our column is remaining the fixed, that is the starting column. So we will write that here. And once this starting column also get processed, so we have to now update our starting column to the next column. To do that, what we will do is we will write starting column plus plus plus, signifying that we have reached into the right side. We have processed this. Now our new boundary is in the next column. Starting column plus plus plus. And at last we will just return our answer. So I hope this should work. Also, when we are doing these things again and again, what we have to do is we have to check in each, after each for loop, that it can also occur that after this for loop our this thing breaks. So we need to like check these s underscore r less than equal to n underscore r, and this condition we have to check again and again, because we are updating our variables inside this while loop. So it can occur that somehow after this for loop, when we are updating our starting row to starting row plus 1, this condition breaks. But if this condition breaks, we have to stop. But currently in our code we are not breaking. If our starting row plus plus goes out of the bound, we are still doing all these things using this new invalid starting row variable. So we need to restrict that. So we will write a internal condition of the same again and again, that do this only if the conditions met. Here also we need to write the same condition. Here also we have to write the same condition. I hope this is clear why we are writing this condition if condition again and again, because we will break our while loop when this condition breaks, but we are updating these variables internally also. Let's suppose after this for loop, when our s underscore r updates, this condition breaks. In theory we have to like break our while loop when this condition breaks, but there is no check inside this. That's why I am adding these checks again and again to counter that thing. Our end row. So yes, all the test case passed and our solution is getting accepted. This is quite easy question if you try to simulate the process. Basically in this question we are just simulating the spiral ordering, how they have defined that. We are just doing that and maintaining the four variables for our boundary checks. Now let's just try to do this third question for our matrix questions of this playlist. For this question we have given an m cross n matrix. This is again a rectangular matrix. If an element is 0, set its entire row and column to 0. And you must do it in place. So we can't define a second matrix of m cross n size. That will violate the question's conditions, question's requirement. So this question is asking that whenever we encounter a 0 in our original matrix, we have to set its column and its rows to 0. See this element that is at row 1 and column 1 is 0. So we have to set all the elements that are present in its column and its rows to 0. And we have to return the matrix using in place operations. Here also see, these two are zeros present in the original matrix. So we have to return a new matrix where the rows and the columns of wherever the 0 is occurring gets changed to 0. See here in the 0th column and 0th row, 0 is occurring. So we need to change all the elements that are in the same column and same row to 0. I hope this is clear. The question's problem statement is clear to you guys. So again, let's just define the size. As we have again a m cross n matrix, so we will do something like int m is equal to matrix dot length and int n is equal to matrix of 0th dot length. To solve this question, let me just try to explain that. Let's suppose we have something like this. The second test case I am copying 0 1 2 0 3 1 3 1 5 4 5 2. You can clearly see occurrences of zeros are 2. So now we have to change all the elements of this row to 0 and this column to 0, and again for this 0 we have to change these row element to 0 and this column's element to 0. So our new array that we have to return will be like this. Because of the first 0, our array will become like this. Because of this 0, these two elements will change to 0 and these row elements will change to 0. For this 0, this column's element will get changed to 0. Rest all will be as it is. So we have to return this as our answer. Yep. So how to think and how to solve this question? What we can do is we can store the occurrences of the zeros in an array. Let's suppose we will make a row array and we will make a column array, and in this row and column array we will initialize it to 0 first, and whenever in a row or a column what we will do here is that whenever any 0 element occur in our matrix, we will update that row and column to 1 respectively. So let me just show you how we are going to approach this question. Let me just quickly do a dry run. Here row of 0 initially rows array will look something like this. As there are 3 rows, so it will be an array of size 3, signifying the first row, second row and the third row. And initially our columns array will be of size 4, as there are 4 columns. Now we will run a nested for loop in order to access all the elements of the matrix. Nested for loops, something like for I to row size, then for j to column size. By doing this, we will go to all the matrix places that are possible in the matrix, and we will check that if our current element where we are using this ith iterator and jth iterator is 0 or not. That we will write this if condition, that if matrix of row comma j is equal or 0, if that is the case, we will update row and columns matrix respectively. We will do something like this. We will do row of ith to be 1 and we will do column of jth equal 1. As you know, the row is getting represented by this ith thing, so we will use I here, and as you know, j is for the column, so we will write this j here. Now after this for loop, what our rows and column matrix will become is something like this, that after this for loop, our row matrix will be something like this. See, for there are this element that is 0, so this if condition will run and our row of 0th will become 1, because we are in the 0th row where this 0 is occurring. So our row matrix will become something like this, 1 comma 0 comma 0, and our column matrix will become something like, see, in this column there is 1 0, and in this column there is 1 0, and this is 0th and this is 3rd. So this will be our column matrix after the for loop. As you can clearly see that in this rows and columns, whenever there is one occurring, we have to make the respective column or row to 0. So what we can do is we can go to row and find wherever there is one occurring in that respective row, we can convert that row into all of the zeros if we encounter any one. And how to do that using for loop? What we can do is we will run our again for loop from I to n for row. We will extract that if your row of ith is equal to 0, is equal to 1, that we have found this one here, and we now have to make all the elements of this row equal to 0. To do that, what we can do is we can write again a for loop for j to m. What we will do is we will make matrix of I comma j equal 0. And for the column wise, we can do the same again. We will run again a for loop for j equal 0 to m, that if column of j is equal 1, we will run a for loop from I to n, and we will do matrix of I comma j equal to 0. By doing this, whenever we found a 1 in a row, basically this 1 in a row matrix signify that at the 0th index there is 1 0, and whenever we found this 1 in a row, when we run this second for loop, we will make all the rows element of it to be 0. Similarly, whenever we find that in a particular column index there is a occurrences of 0, we will update that column, that in the column of 0th index there is 1 0 occurring, and at the column 3rd there is 1 0 occurring again. And then when we run this third for loop, we will find that wherever that is occurring and make all the columns of that particular column to 0. I hope this is now completely clear. So let me just quickly write the code. For this we needed a row and a column array. So let me just define those. Int row is equal to, as there are m rows, so we will write new int and define the size to be m. And as there are n columns, we will define column array size as new int of n. Now we have to run this for loop in order to fill these rows and columns array and find in which rows or which column this zero is occurring, zeros are occurring. So for int I equals 0 to I less than your m I plus plus, then for int j equals 0 to j less than n j plus plus, if we found occurrence of 0, that if matrix of I comma j is equal 0. So we have found that here in this ith and in this jth 0 is occurring. Then we will update our row and column matrix in order to capture that one. That row of ith is equal to 1 and column of jth is equal to 1. I hope this is now clear. After this nested for loop, our rows and columns array will be filled with something like this. That whenever a zero is occurring, whenever the zero is occurring, we are making those rows and columns 1 respectively. See, in this example also, only this is the 0 that is there in the matrix and this is the 0 that is there in this matrix. For this 0, the rowth index is 0 and the column index is 0. So we are making the rowth index 0 to be 1 and column index 0 to be 1. And for this 0, this is also in the same row 0th and column 3rd. So we will make row 0th 1 and column 3rd 1. That's how we are filling this. And whenever now in the second and third for loop, whenever we encounter any one in the respective row or a column, we will make that whole row to 0 or that whole column to 0. So this for loop is for the row, that for int I is equal to 0 to I less than m I plus plus, that if row of ith is equal 1, we have found our targeted thing, we will make whole row to be 0. We will write again a nested for loop, that for int j equals 0 to j less than n j plus plus, and we will do matrix of I comma j is equal to 0. By doing this, what we will do is, whenever we found our row of ith to be 1, we will run a for loop and we will make all that row element to be 0. Similarly, we will do the same for the column thing. For int I is equal to less than n, whenever column of ith is this time 1, we will run again a nested for loop for the rows and we will make matrix of j comma I to be 0. So all test cases passed, all 200 test cases passed, and our solution get accepted. So we can move to the last question of this matrix playlist here. Let me just remove this. Okay, so this is just a binary search code. I have already made a playlist on binary search questions, so I hope you know this is just a binary search recursion algorithm that is written here, that we are calculating our mid. Then if the target is equal to mid, we will return true. Otherwise, if the target is in the left part, we will reduce our end, and if the target is in the right side, we will increase our start. And if our start becomes greater than end at any point, we will return false, signifying that we have not found our answer in the whole array. And binary search takes an array as an input, a sorted array as an input. So now let's just quickly see the question problem statement. Write an efficient algorithm that searches for a value target in an m cross n integer matrix. The matrix has following properties. Integers in each row are sorted in ascending from left to right. In every row, the integer is sorted. See this. The 1, 4, 7, 11, 15, and similarly 10, 13, 14, 17, 24. All the rows are sorted. And integers in each column are sorted in ascending from top to bottom. Okay, so the columns are also in a ascending thing. See this. 1, 2, 3, 10, 18, 4, 5, 6, 13, and 21. Both of them are sorted. Rows are also sorted and columns are also sorted. What we have to do is we have to find the target. We have to find the target in an m cross n matrix. So we have to find, let's say if the target is equal to 5, we have to return true if that 5 is in the matrix. Otherwise we have to return false. Okay, so here what we can do is, let's say suppose we are trying to find 5. What we can do is we can run a for loop here to get our appropriate row, and then if we get our appropriate row, we will run a for loop there. No, we can't do that. Okay, let me just write the brute force approach, that we will search in all the ith row. That suppose we will run our for loop from 0 to n. We will run our for loop from 0 to the row's length, and we will go to each row and search using binary search that if there occur a 5 or not. Let me just write the code, that int m is equal to matrix dot length and int n is equal to matrix of 0 dot length. I less than your m I plus plus. What we will do is we will search the target in each row. So our time complexity will be something like m log n, because m for this for loop and log n for the binary search on the column array. So if binary search of starting will be 0 of the array, ending will be n minus 1, because each columns, basically there are n minus 1 columns in the 0th based indexing, and our target will be same target, and our array will be the row, a particular row. So how to pass that here is that we will call matrix of ith here. If we found our target, we will just simply return true, otherwise we will return false. So I don't know why this was marked the medium question, because it was the pretty much very easy question. We just write a binary search and we just search our target using the binary search in each row of the matrix. So to get into the each row of the matrix, we just run a single for loop, and in that for loop we are passing that particular row here to our parameter of the binary search, because it accepts a sorted array as an input. So our solution get accepted. Now we have done all the matrix questions also, so we are in the good position now.